Welcome back to the madness of my chemistry. Today we are starting a brand new unit. We are going to be talking about chemical reactions. Now, funny thing about this unit, we've been talking about this all year long. You just haven't really known we've been talking about it. So, to kind of give you the basic background here, what is a chemical reaction? Well, a chemical reaction is we change something into something else by chemical means. And we always set it up as the reactants being the things we start with. There could be one, there could be two, there could be seven. An arrow shows us that a reaction has occurred. And then the products are the things that we end with. Okay? And remember, this is a chemical change. We are changing something. But what you've got to remember is during a chemical reaction, bonds can be formed. They can be broken. They can be both, okay? You can break one and form another one. We're going to get into that part later, okay? Your atoms are rearranged, okay? I'm totally taking my pieces and juggling all of them up and making something else. But you are not creating or destroying atoms or mass. We have talked all year long about the laws of conservation. Sometimes we talk about the law of conservation of mass, where mass can't be created or destroyed. Other times it's the law of conservation of atoms, can't be created or destroyed. Same idea, all we're doing is we're taking our parts and rearranging them. Now, this is kind of hard to wrap your brain around when it comes to chemical reactions like burning. It's hard for you to realize when you take a piece of paper and you light it on fire, you're not destroying anything. All you're doing is turning that paper into ash, smoke, and steam. The smoke and the steam are part of the reaction. If you kind of enclosed the whole thing and you measured all the parts, nothing will have gone away. Another review from earlier this year is how do I know if a chemical reaction has occurred? Well, there's 4 pieces of evidence we look for, and again, we learned this earlier this year. These are not necessarily indicative of a chemical reaction. They can happen with a physical change, but they're pretty good hints that a chemical reaction has occurred. For example, if a gas has been produced, maybe you see bubbles, maybe you smell something. Now, if I boil a pot of water, I'm going to see bubbles. That doesn't mean it's a chemical reaction. So it's not the end-all, be-all. These are just things we look for. Number 2 is if I form a precipitate. Remember, we did a whole lab on this. Put 2 solutions together that are clear and they turn cloudy. Put 2 liquids together, you get chunks. Number 3 is if you see an energy change. You see the release or absorption of energy. Maybe something gets hotter, something gets colder, maybe light is given off. And then the 4th one is a color change. We did that lab earlier this year where you had a clear solution and another clear solution and it turned neon pink. So that's kind of your background for chemical reaction. When we're writing them, okay, you guys have seen these before. The joys of biology is I know you have seen CO2 plus H2O yields C6H12O6 plus O2. That's photosynthesis that you learned about in biology. But sometimes we add some extra stuff in chemistry. We add information about state of matter. All right, if you see an S written beside something, it means it's in solid form. So if I was going to tweak this reaction up here and make it a little bit more accurate, okay, I could put an S in parentheses after this glucose. If you saw an L beside something, it means it's a liquid. Okay, and we're going to come back to this, but there's actually very few things that end up being pure liquid. I'll come back to that. If you see a G, I know you can tell where this is going, that would mean it's a gas. Okay, whoops, sorry about that. Go back to this yellow again. In fact, I'll fix my L for you, make it a little easier to keep track of everything. Oh my goodness. Oh, there we go. Okay, CO2 is also a gas. And then there's a 4th option. Now, you don't see it in this particular reaction, but the 4th option is AQ. AQ is what we call an aqueous solution. That means it is something dissolved in water. Let's say I was doing a reaction with salt water. I wouldn't say plus NaCl plus H2O. I would say plus NaCl AQ. The chances of you having liquid salt are very slim. We've talked about this. Salt melts at like 1400 degrees Celsius. So if you have NaCl with an L beside it, you're telling me it's 1400 degrees Celsius, you have melted solid salt down to its liquid form. Yeah, that probably didn't happen, okay? If it's dissolved in water, probably did happen, That's when we see that AQ or aqueous. The other thing you've got to know about chemical reactions is sometimes over top the arrow, okay, so this would be, A plus B makes AB. Over top the arrow, something will be written, okay, like PT or light or energy or electricity. What that indicates is a catalyst, all right? This particular catalyst happens to be platinum. A catalyst is something that speeds up a reaction. It's not part of the reaction. It's not being used. It's not a product. It's not a reactant, okay? It's something that's just making the reaction go faster. In biology, you learned about this because you talked about enzymes. All right, so the big thing we're going to do today is we're going to talk about balancing equations. Now, if you learned this in middle school and you think, oh my gosh, I can't do this, you're wrong. Oddly enough, sometimes people can't do this in middle school. By the time they get to high school, it's really ridiculously easy. All you have to remember is we've got to have the law of conservation of mass, which means we can't destroy anything, okay? So if you're a picture person, let's say we have carbon plus oxygen, which we know is a diatomic, okay, producing carbon dioxide. There's my carbon, bound to an oxygen over here and an oxygen over here. If I look at the beginning and end of this, okay, I have one carbon on this side and one carbon on this side. I didn't lose anything. If I look at my oxygens, I have two O's over here. I have two O's over here. I didn't lose anything. So this one is a pretty easy equation to look at, okay? Carbon plus O2 creates carbon dioxide. Easy. But other times, it's not automatically perfect, okay? I'll use my pictures again. Let's say this time I have carbon plus oxygen again. Oxygen's a diatomic. But this time my end product is carbon monoxide. Carbon monoxide only has one O. Okay? When I'm looking at this, all right, C plus O2 yields CO. That is not a balanced equation. Okay, we only have one oxygen over here on this side, and we clearly can't just have one disappear. So what do? You cannot just turn the end product into carbon dioxide. That's a totally different molecule. So the only thing we can possibly do is add another one of what we've already got over here on the side. Okay, that takes care of my two oxygens. The problem, of course, you see, is now I have two carbons. So that means in order to make this reaction happen, I must have started with two carbons, okay, one oxygen, because it's diatomic, to get two carbon monoxides. That is a balanced equation. There are two carbons here, two carbons here. There are two oxygens here and two oxygens here. So that's your idea of what you're doing. So I'm going to show you a different technique. It may not be the one that you used in middle school. Some of you guys are going to be able to balance equations in your head. That's great. Go for it, all right? There's nothing wrong with you doing it in your head. But if you're not a big doing it in your head kind of person, try my method, see how it works for you. If it doesn't work, we'll find another one. But no matter what, there's a couple things you have to remember, okay? Rules, if you will. Okay, the biggest rules I can tell you is you've got to balance things one at a time, and you can only balance by adding coefficients, all right? Coefficients are the number in front. So if I have NaCl and I need two chlorines, okay, I cannot do that. That's wrong, okay? You're not allowed to add a subscript, okay? Never, ever, ever add a subscript. If you want two chlorines, the only thing you can do is put a coefficient in the very front. And you're right, that gives you another sodium that you then have to deal with. Every now and then I have somebody try to do this number and they say, look, I added a coefficient. Yeah, you can't do that. Okay, you cannot stick one in the middle. You're not that cool. All you can do is add them to the front. Okay, that's the biggest thing you've got to remember. The other piece of advice that I can give you is start with things that only appear once. Okay, if you're looking at an equation, all right, CH4 plus O2 yields CO2 plus H2O. Okay, if you're going to balance this, you are going to want to start with either carbon or hydrogen. Definitely not oxygen. When it appears like two different places on one side, that makes your life very, 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 very difficult. Okay, and you don't want to mess with it until last. So here is my technique. This just takes some practice. The equation I'm going to give you is H2 plus O2 yields water. Okay, so my technique is to, underneath your arrow, write the elements that are involved in this equation. In this case, it's hydrogen and oxygen. Then the first thing I'm going to do is I'm just going to count how many I have on each side. I have 2 hydrogens here. I have 2 oxygens here. On this side, I have 2 hydrogens, and I only have 1 oxygen. So now I'm going to look down here at my little chart, okay, and I'm going to say, all right, what do I need more of? Well, I need more oxygens. And I need more oxygens on this side. So the only place I can add a coefficient is right here. So I have to decide what number I can add there in order to balance out my oxygens. Now, a lot of people will say, oh, I just need 1. Well, if you add a 1 there, you already have a 1 there. So that's not changing anything. So I have to add a 2 to have 2 H2O molecules. If I have 2 H2Os, that's literally saying H2O, H2O. Okay, so now I'm going to update my chart. When I have 2 H2Os, I now have 2 oxygens. Yay! But I also now have 4 hydrogens. So I have to look at the whole thing again. My oxygens are balanced, but now my hydrogens are out of whack. So now I have to decide, what do I have to do? Well, I need more hydrogens on this side. So looking at my equation, I have to add a coefficient there. What coefficient can I add to make these equal? You probably already said it. I can add a 2. Okay, that gives me 4 and 4, 2 and 2. For the record, I never need to see any of this. I'm never going to look at it. This is you keeping track of your work. What I want to see is this. All right, so let's look at another one. Okay, let's try N2 plus H2 yields NH3. Same idea. I'm going to list my N and my H. Okay, I have 2 N's over here, 2 H's over here. I have 1 N over here. I have 3 H's over here. Okay, well, everything only appears once on the side, so I'm just going to start with the first one. I'm going to start with my N's. So to balance out my N's, I know I need more on my right side, so I'm going to add a coefficient of 2. Okay, that gives me 2 nitrogens. But it also is going to change my hydrogens. Now, in this case, you got to really think about, okay, what do you do with this number? What you have now is you have 2 NH3s. So when you add up the pieces, that gives me how many H's? 6. Okay, so it's coefficient times subscript, and think about it and you'll understand why. So now going back to balancing, I look at my equation again. Okay, nitrogens are good. I got to balance out these hydrogens. So what number do I want to add to make that 6? I want to add a 3. Okay, so again, nobody cares about your chart. We just care about the balanced equation. All right, so let's look at a couple slightly more difficult ones. All right, let's look at the one I mentioned to you earlier. CH4 plus O2 yields CO2 plus H2O. All right, this one has carbon, hydrogen, and oxygen, but that oxygen is in more than one spot. So all I know is I don't even want to think about balancing that oxygen until last. I do have to think about with him, though, how many oxygens are on this side. There's 2 there, there's 1 there, so there are 3 of them. But again, let's balance everybody else first. You'll see why. Carbons are good. I ain't messing with them. So now we'll go down to hydrogen. Okay, I need more hydrogens on this side, so I'm going to add a coefficient of 2. How did I know that? Because I need 4 total hydrogens, and it's 2 times 2 that gives me 4. So now I've got to update my chart. Now this time, I have 2 oxygens here and 2 oxygens here. So that gives me a total of 4, which means you can pretty readily see what I have to do on this side to make it work. Again, the chart is not ever going to even get looked at. It's for you. So whether or not you use it, you finish it, you complete it, is your call. We're going to look at 2 more different things. Okay, one, let's look at something with polyatomics. Okay, AgNO3 plus copper yields copper nitrate, it's actually copper 2 nitrate, and silver. All right, so this time when you list them, you have a choice. You can absolutely list every element separately. It'll work like a charm. 1, 1, 3, 1. Nothing wrong with that. Okay, and you can balance it that way. So over here, you'd say there's one of those. Now you got to be a little careful. There's 2 N's and 6 O's, because remember, it's 2 NO3s that I've got when I put it in parentheses like that. And then 1 silver. So you can totally do it that way. Works like a charm, no problem. But what some people, myself included, like to do is I like looking at this nitrate as a unit. Okay, so it's almost like I'm going to go ahead and stick him in brackets over there, and I'm going to look at silver, nitrate, and copper. So I have 1 silver, 1 nitrate, 1 copper. I have 1 silver, 2 nitrates, and 1 copper, because I'm looking at NO3 as a package. Now, for some people, this is really difficult to do. If that's you, don't do it. But if it works for you, everything is the same. Okay, I need more nitrates on this side, so I'm going to add a 2. Okay, now I have 2 NO3s, and I have 2 silvers. Add a 2 there. Everybody's happy. Okay, so however you do the ones with polyatomics are up to you. All right, last one that I want to show you today is what do you do with the ones that tend to be very, very grumpy? And trust me, you will get these reactions that are very difficult to balance and very grumpy. Here is an example. Let's do C2H6 plus O2 yields CO2 plus H2O. Okay, so I'm going to go through and start balancing this guy just like always. CHO. 2 of those, 6 of those, 2 of those, 1 of those, 2 of those, 3 of those. Piece of cake, right? So I'm going to add a 2 to that. Okay, here, let me switch colors, make your life easier. I'll add a 2 to that. Okay, that changes this to 2. And then I'm going to update my oxygens, and I got 1, 2, 3, 4, 5 of those. Okay, so far so good. Now I'm going to fix my hydrogens. So I'm going to put a 3 there, because that gives me 6 of those, right? So I'm golden here. Now I count my oxygens, and I've got 1, 2, 3, 4, 5, 6, 7. So what number can I add in front of that O2 to give me 7? We have a problem. Okay, no, I know some of you want to really badly. You cannot add 3.5. There's not a 0.5 option. Okay, this is going to happen to you balancing equations, where you get to a point and you're just like, this isn't working. Okay, and it's not going to work, no matter how long you stare at it like this. So here's the trick that will make you crack up laughing. If you run into a brick wall, just like we just did, erase everything you have done thus far. Okay, yes, pencils are your friend. Okay, so I'm going to erase it all. I'm going to go back to my starting point, 1, 2, 3. And then, believe it or not, my solution is stick a 2 in front. I'm so being serious right now. My solution to this problem is put a 2 in front of the first thing, period. That is exactly the way I'm going to solve this problem. I don't even care what the equation is, stick a 2 in front. And now I'm going to try it again. 4 of these, 12 of these. Okay, that's what updated from that right there. Now I'm going to go back to balancing. I'm going to put a 4 there. Gives me 4 carbons and 9 total oxygens. So I need 12. My carbons are good. Let's look at my hydrogens. Put a 6 there. Okay, that gives me 12 of those. Now let me total up my oxygens. There's 8 right here. There's 6 right here. That's a total of 14. I can get 14 by putting a 7. Okay, so I end up with a nicely balanced equation, and all I did was stick a 2 in the front. If you get really evil ones, the 2 won't work. So guess what you have to do next? Yep, you guessed it, put a 3 in the front. That sounds so basic, but I'm telling you that really is a good solution to kind of running into a wall with balancing equations. So this is something that takes a lot of practice. We've got a lot of practice we're doing in class. If this method, if this whole thing is still getting you stuck, come see me or YouTube other people's videos. There's some great ideas out there and great techniques. Just don't give up because this is doable once you get the hang of it.